Since the beginning of time, all the matter in the universe has been governed by precisely balanced laws and constants. During an interview with Robin Collins, a philosopher with degrees in mathematics and physics, Strobel learned how these laws offer compelling evidence for a creator and conspire to make the universe habitable for life.
The laws of physics are balanced on a razor's edge for life to occur. For example, if you didn't have something like gravity that pulled matter together, you would never get planets, you wouldn't get stars, you wouldn't get any complex organisms. If you didn't have the strong nuclear force, there would be nothing to hold protons and neutrons together in the nucleus. And so you wouldn't have any atoms, so no chemistry. If you didn't have the electromagnetic force, you would have no bonding between chemicals. You'd have no light, and the list goes on. So you need all these sorts of fundamental principles have to be in place in order for life to occur. Wipe out one of those principles, wipe out one of those laws, no life.
Strobel learned that life also hinges on the precise strengths and relative values of many different physical constants. One example of this fine-tuning is the force of gravity.
Imagine a ruler divided up into 1-inch increments and then stretched across the entire universe, a distance of some 14 billion light years. For the purposes of illustration, the ruler represents the possible range for gravity. In other words, the setting for the strength of gravity could have been anywhere along the ruler, but it just happens to be situated in exactly the right place so that life is possible. Now, if you were to change the force of gravity by moving the setting just 1 inch compared to the entire width of the universe, the effect on life would be catastrophic.
No large-scale life forms could exist. Anything that was more than the size of a pea would be completely crushed. So you might be able to get life of a very, very primitive sort, such as bacteria, but you could never get conscious observers.
The strength of gravity is just one of at least 30 separate parameters that must be finely tuned to produce a life-sustaining universe. Another example is the cosmological constant.
The cosmological constant describes the expansion speed of space in the universe. If space expands too quickly, then the universe will spread out so quickly that material objects can't form. So you can't get stars and galaxies and planets and the types of things that we, of course, take for granted in our universe.
Physicists have determined that the cosmological constant is fine-tuned to 1 part in 100 million billion 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 billion. Such precision has been compared to traveling hundreds of miles into space, then throwing a dart at the Earth and hitting a bullseye measuring 1/trillionth of an inch in diameter, an area less than the width of a single atom.
Just consider those two parameters, gravity and the cosmological constant. Their level of fine-tuning is to a precision of 1 part in 100 million trillion 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 trillion. I mean, that's like 1 atom in the entire known universe.
This fine-tuning is also evident at the atomic level. The strong nuclear force binds atoms together. If the strength of this force were to decrease by 1 part in 10,000 billion 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 billion, the only element left in the universe would be hydrogen. Again, chemical life would not be possible. The fine-tuning of the laws and forces of physics is so precise that few theorists are comfortable invoking mere chance as an explanation, unless our universe is not the only roll of the dice.
If the universe looks like it's fine-tuned for complex life, maybe there's a fine-tuner. Maybe it was fine-tuned for life. And this has certain unsavory theological implications. And so it's not surprising that those committed to a fundamentally materialistic view of reality would try to find an escape hatch. And the most popular escape hatch for this theological implication of fine-tuning is this idea of multiple universes.
As its name suggests, the theory of multiple universes proposes that our universe is not alone. Instead, it is part of a vast ensemble of universes, each with a different set of laws and constants.
If there's only one universe, then the conclusion that the universe looks fine-tuned because it is fine-tuned is inescapable. But if our universe is just one of a vast set, then you seem to have more resources to play with. Chance gets a new lease on life. I sometimes try to imagine what physicists have in mind that postulate this idea of multiple universes. I mean, what would the generator look like that creates them? Maybe it's like a giant monolith that has dozens of different dials, each of which has to be set to the right physical constant.
If we think of these parameters as dials, each of the dials is different. So if you produce enough universes with enough different dial settings, eventually, just by chance, you get one just right. So you might have to produce a trillion universes. But eventually, if you have a generator that's just spitting out just an enormous number of them, then it gets the right dial setting. And then by just chance, you get conditions right for life. So it's a huge cosmic lottery. That's the idea.
It's an interesting idea. I mean, there's really only one problem with it. There's no independent evidence that it's true. Besides, it really just pushes the question back a step, because we could still ask, who built the generator?
The suggestion of multiple universes strikes me as a desperate attempt to explain away the obvious, which is that the universe is finely tuned by an intelligence to sustain complex life. An intelligence that must be beyond the constraints of time and space.
Strobel's journey through a universe finely tuned for life inevitably led him home, to the blue jewel of our solar system, the planet Earth. There he encountered another array of critically balanced conditions essential to human existence.
When I was an atheist, I saw planet Earth as being one of probably billions of planets just like it all over the universe. I saw our sun as being an average, undistinguished type of a sun. I figured as I looked up at the stars at night that there must be millions and millions of advanced civilizations out there. I just thought there was an ordinariness to our situation. This line of reasoning was totally consistent with my atheistic worldview. But what I learned later is it is not consistent with what science is revealing about the Earth.
Strobel's investigation caused him to consider the many conditions necessary for a life-sustaining planet. In the process, he was introduced to the science of astrobiology and astronomer Guillermo Gonzalez.
I'm an astrobiologist, and what motivates me is just to examine the conditions necessary for life and look elsewhere in the universe and see if those conditions are met anywhere else. And the answer could be yes, and the answer could be no, and either answer is interesting.
For more than a decade, Guillermo Gonzalez has researched the characteristics of a planet required to support complex life. Estimates vary, but a current list of these factors would number at least 20 and include an oxygen-rich atmosphere, liquid water and large continental landmasses, a home star of the right temperature and mass, an orbital path that is neither too far nor too close to the home star, a moon large enough to stabilize the tilt of the planet's axis and the movement of its tides, a magnetic field strong enough to deflect the sun's radiation, and a position in the relatively narrow habitable region of a spiral galaxy.
All these factors have to be met at one place and time in the galaxy if you're going to have a planet as habitable as the Earth, which you need for complex and even technological life.
Theorists have attempted to calculate the odds of all the necessary factors for life appearing at the same time on the same planet. A conservative estimate is 1 chance in 10 to the negative 15th, or 1/1000th of 1 trillionth. On those terms, even when compared to the billions of suns and possible planets in our Milky Way galaxy, the probability of even a single habitable world appears unlikely.
There are many probabilistic resources in the galaxy, but on the other side of the coin are all these factors that you need. You have to get just right in order to have just one habitable planet like the Earth. And that leads me to conclude that yes, we're rare in the galaxy.
Gonzalez's study of the Earth's habitability led him and colleague Jay Richards to expand the scope of their research. They began to examine how a life-sustaining planet like Earth may also give its human inhabitants access to the mysteries of the universe.
I don't think there has ever been a time in the history of the human race in which at least some people haven't contemplated these questions. We ask, why can we see distant galaxies, millions of light years away in the universe? Why can we postulate what's going on inside atoms or inside black holes? Why are we able to discover things about the universe, to answer questions about its age? For most scientific discoveries that we're able to make, these sorts of things can't be explained in terms of the survival of the fittest of our distant ancestors. Not only our ability to do science, but the openness of the natural world to science just completely outstrips the sort of reductionist and Darwinian explanations that we're used to.
In response to this evidence, Richards and Gonzalez have argued that our ability to make scientific discoveries is no fluke or accident. Instead, it points to an underlying purpose behind the universe. It is actually designed for discovery.
Guillermo Gonzalez and I spent several years pursuing a hypothesis that those rare things that life needs in a planetary environment, those things that make a planet habitable, also set up the best set of conditions overall for scientific discovery.
There are many examples of this correlation, including our planet's oxygen-rich atmosphere, both a critical requirement for our survival and a transparent window that allows us to explore the distant universe. The Earth's precise distance from the Sun and the size of its moon and home star. These factors not only control our planet's temperature, axial tilt, and the movement of its tides, they also ensure perfect solar eclipses, phenomena that have provided scientists with invaluable data about the composition of stars and the properties of light. And our location in the Milky Way. The Earth is positioned between two spiral arms within a relatively small region where life is possible. As a result, we enjoy an excellent platform for clear, unimpeded views of our galaxy and the rest of the cosmos.
I think God intentionally created a habitat for us that allows us to see Him through the creation that He has left behind. And this habitat is conducive for us to do scientific research. It didn't have to be that way, but it is. Why? Because I believe that by doing science, we find God.
The final leg of Strobel's investigation transported him from the deepest reaches of the cosmos to the microscopic universe of the living cell and the science of biochemistry. There he encountered more challenges to Darwinian evolution and new evidence of design.